Okay. We're having this 840 G3. Yeah? This is 840 G3, and the client says that when battery is connected, it does not power on, and it does not charge the battery. They've actually tried replacing another battery, but to no avail. So he decided to bring it here for repair, and let's see and check it out if we will be able to repair this. Yeah, so usually the first culprits, actually the machine powers on very well, and that one you can test. The machine powers on without the battery. With the battery, it doesn't power on. So plugged in, and I think the power button is not connected. So plug in and press power button. It's taking 0.6, 0.4. So that means it's actually powering on. Should have a display. Yeah, it's powering on, but actually brought it without the battery, and now I don't have the battery as well, so I cannot really verify if it's powering on or not with the battery. What we can do is to check if there is any fault within the charging section, or the input section, or any section related, or to the section related with the battery. Yeah, that is all we can do. So let's get in and see if upon you're going to find any fault. Find any faults. So we remove the motherboard. What we just need to do is to find a fault that is inside related to all those. But then if it goes beyond that, that is, if we need to have a battery to do the, definitely we'll have to have a battery to do the testing, because we cannot give it until we're sure it is charging, though the client says it was not charging and there was no powering on when it is connected. So if we find the fault, well and good, the better for us. So what we're going to do first is to, definitely there's no short in the main power rail because it's powering on, and I'm quite sure there's voltage in the main power rail, so that is something we can check and verify. Check for main power rail. Just a minute. Okay. Okay, fine. So we can check for main power rail. We'll switch to microscope. Yeah. We'll check the main power rail for voltage, and here and here we are having nothing, probably ground, and here 19. So we're having 19 volts in the main power rail, which is present. So what we need to do next is check the input. We're going to check the MOSFETs in the input to see if there is a short. Probably voltage is passing through, and that is a non-issue for us. So let's check the input. So from here, fine. So power gets in through here. This is our first MOSFET. Let's confirm it's okay. The MOSFET is okay. Then it goes into the second MOSFET, and the MOSFET is okay, and the current sense resistor is okay, having 0.2 ohms. That's okay. There's also a MOSFET here, which seems okay. Let's check for any short around the charging IC. That one is a resistor. That should be okay. That's okay. Then what else? So BQ24780S. So that is the BQ chip we are dealing with. Yeah, the BQ24780S. That is a BQ chip we are dealing with. So we'll check that later. So everything here seems to be okay, and now let's shift to this other side where we have the charging coil, and check. Probably where's the positive? Positive should be, let's check for ground. That is, so there's the ground. This is positive, and it is connected to not that place, not that area. And not that area. This one is a power supply related to the CPU, right? It's having 9 ohms. So this is a power supply related to the CPU. This one as well. This one as well. And these ones are related to the CPU, right? So probably let's remove this casing to see exactly if okay. So you're having a MOSFET here. Let's plug it in and see the voltage that is going through that area. I'm closing the heatsink. Okay, fine. Let's first check the resistance of the coil. Probably that can give us a hint if there is any shorted line. Oh, wow. Okay, sorry I was interrupted. So let's check the resistance here. This one is 15 ohms. This one is 15 ohms. This one looks okay, and this one looks okay. And which one else? We have one here which looks okay. Wait, I can actually see a short here. A short of 0.2. Is that normal? This is a positive line. This is a MOSFET probably connected to the positive line, and it's having 0.2 ohms. 0.2 ohms. Or is it ground? Or is this a MOSFET connected to ground? Why is it having that? Why? Let's check something. Okay. So what we could actually be looking for is the comeback MOSFET. The comeback MOSFET connects the 19 volts to the charging area, and that could be an issue. So it could be the comeback MOSFET, it could be the BQ chip 24780S. So if that does not work, we'll go for the BQ chip. We will go for the BQ chip. Yeah. Okay. From this side, this part, it connects. Let's see. Because we are trying to trace the positive line from here, and positive. Then this one is ground. Wait, is this one ground? So the comeback MOSFET is connected on the ground or what? Because I fail to understand this. Because this one is beeping, right? Having 0.2 ohms. This side is not beeping. So there is a short. This one is ground, and this one has 23 ohms, right? And this one has 10 ohms. This one has 0.2 ohms. This side looks okay. In this place, this one also looks okay. This design is pretty confusing. It's pretty confusing. pretty confusing. So this one to ground, nothing. This one to ground, 0.3. This one to ground, 23. But here to ground, 23. Are they CPU power supplies? Are they CPU power supplies? Are they CPU power supplies? You can only know that by powering it on again and checking the voltages. Okay, fine. Power it on and checking the voltages, right? So here at the pad we are having okay, fine. So here at the pad we are having 19 volts. We're having 19 volts, right? And at this point we are having nothing, right? We're having nothing here. So 19 volts, and we are having nothing here. And this side we're having nothing as well. So there is a problem somewhere, because probably the gate of this MOSFET is having nothing. The gate of this MOSFET, oh, you can't see, sorry, the gate of this MOSFET is having nothing, and here we are also having nothing, but here we are having 19.5 or 19.15. Here, I don't know if you can see, the view on my microscope is quite low, so just bear with me. So at this point we are having 19.15. So basically what is happening here is this could be the charging coil, right? The 19 volts come from here, then comes from here and goes through, and therefore we should be having 19 volts here. There is nothing on the gate of this MOSFET, and we should look for the driver of this MOSFET, and the driver of this MOSFET is the BQ24780S. Is the BQ we checked. So the MOSFET is not shorted, and we haven't checked extensively for the BQ. And so what do you say about that? What do you say about that? It could be the BQ chip itself, and probably it could be the BQ chip. It could be the BQ chip. Okay. Now that we don't even have a battery to test, we must get the chip first and try with another chip upon it's going to work. But this design is really confusing. You'd expect at this point to be having 19 volts, or the charging voltage, or at this point to be having 8 volts, the charging voltage, probably 8 or 13 or something, the voltage on the battery. Okay, I had to get another G3. I had to get another 840 G3. Okay, fine. Just for comparison, just to check whether the MOSFET is connected to ground, because it was a bit confusing. We have the same motherboard here, and though it is not working, but we can just confirm some few things. Number one, this one is ground, right? That one is ground, that one is okay. And this coil is having how many ohms? 14 ohms, right? So that one is actually okay. And this coil is having 6.9 ohms, which is also okay. So I think that circuit is okay. And that MOSFET is also okay. Okay, fine. We just confirmed, and maybe whoever we are going to go for is now this BQ chip. But anyway, I need to get a battery for testing. So I'll get a battery to test almost everything. Once we are sure that we know what we are working on, then maybe from there we can continue. I thought we would get some very obvious faults, like maybe a blown BQ chip. The machine wouldn't be working anyway. So let me get another battery, then we can continue. Okay, see you.